All right, so our next unit is electrical principles and technologies. And our first topic is topic 1, electric charges. And so we'll come back and watch this Bill Nye video on static electricity. So materials that attract and repel other materials, they are said to be charged, therefore carrying an electric charge. So how are electric charges produced? So basically when combinations of materials are rubbed against each other or touched or moved closer together, they become charged. So for example, you've probably experienced this when you shuffle across a carpet. The person and the carpet, they develop an electric charge. And then maybe you go to touch a doorknob or something and you might get an electric shock or notice a spark. All right, that's an example. So static electricity, this is a charge that's produced by rubbing or touching objects together. So a more correct term for that is calling it an unbalanced charge. Instead of static electricity, the charges are not, because charges are not stationary, they do move. And then this unit is called coulombs with a capital C. That's the quantity of electric charge. So for example, a bright light bulb allows about 1 coulomb of electric charge to pass through it every second. Right, so here, just looking at the charges, making sense of electric charges. So the charge depends on the balance between positive and negative charges in an object. So here, there's a balance of positive and negative charges, right? So we have a positive, then a negative, positive, negative. All right, so we were looking at this first one here. So positive, negative, positive, negative. If you look through all of this, every positive has a negative charge associated with it. So therefore, this is neutral. It's uncharged. There's equal amount of positive and negative charge here. Here, if we take a look, there's more positive charges. Therefore, more positive charges than the negative charges, right? So there's only like 3 negative charges shown here. The rest are all positive. So therefore, this would have a positive charge because there's an excess of positive charges. And then the opposite is true here. We see more negative charges than the positive charges. So therefore, this has a negative charge because of that excess negative charge. All right, so we'll pause here. Okay, so Benjamin Franklin, he was an American inventor and politician. He was the first to start using the terms positive and negative to describe charges. So unlike charges, those are 2 different charges. So one positive and one negative. And then like charges are 2 charges of the same type. So for example, both are positive or both are negative. So he lived at a time when the discovery of protons, electrons, neutrons hadn't been discovered yet. So he lived before scientists understood that all matter consists of atoms. Okay, so now we know protons, these are the positively charged particles. We know that the electrons are the negatively charged particles, and we know that neutrons are neutral. And so the modern theory is that the unbalanced charges on solid materials are due to the movement of electrons from one object to another. So it's the movement of electrons. Okay, so the laws of charges, this describes the behavior between charged and uncharged objects. So unlike charges, they will attract. Like charges will repel, and then charged objects attract uncharged or neutral objects. So I believe we have a diagram next here. Nope. So just when it says unlike charges attract, so for example, a positive charge and a negative charge will attract. Like charges will repel, so positive and positive will repel, a negative and a negative will repel. Okay, so there are conductors, there are insulators, and there are in-between materials. So insulators, These are materials that do not allow charges to move freely on or through them. So most non-metals are insulators. So think of materials like glass and plastic. These materials, they hold their electrons very tightly. And then conductors, these materials allow charges to move freely. So most metals are conductors, and these materials will hold their electrons very loosely. So if we look at these two diagrams here, here is a rubber balloon, and this one here is a metallic balloon. So when you rub a rubber balloon, the charges remain in place. So shown here, the charges are all kind of in one place. But when you rub a metallic balloon, the metal conductor is allowing those charges to move freely all over the entire surface. So fair conductors, these allow electrons to move, but not at all freely. So here, the good conductors, we have aluminum, copper, gold, nickel, platinum, silver, tungsten. Insulators here, things like cotton, glass, paper, plastic, porcelain, rubber, pure water. And then some fair conductors, silicon, carbon, the human body, humid air, nichrome, and salty water. Those would be considered fair conductors. So semiconductors, these are materials with higher conductivity than insulators, but they still have lower conductivity than metals. So their conductivity is increased by implanting foreign atoms into the pure materials. So for example, if you take silicon with gallium added, that would be a semiconductor. Germanium with phosphorus added, that would be another example of semiconductor. So here, this is an image here, silicon semiconductor, which are used to make computer microchips. Then we have superconductors. These are materials that will offer little to no resistance to the flow of charges. So they are superconductors. Some materials can become superconductors when they are subjected to very, very low temperatures. So minus 137.15 degrees Celsius to minus 273.15 degrees Celsius. So usually they're made of metal alloys and ceramics. They're used for components for electric generators, high voltage power lines, and supercomputers. And they do take up less space. And they can carry higher charges than ordinary conductors. The only downside is the extremely low temperatures that are required. Okay, we'll pause here and watch this video. All right, so neutralizing unbalanced charges. So for example, static cling on clothing. Electrical discharge, this means the rebalancing of an unbalanced charge. So it's usually felt as a shock or seen as a spark. So electrons either enter an object to make up for a shortage, or an excess of electrons leaves the object. And then when we say neutralized, that means the charges have become balanced. So electrical discharges are a very serious safety hazard. They can shock people. They can damage electrical equipment. They can also cause fires and explosions. So there's a method here called grounding. So it's a method of neutralizing unbalanced charges. So basically it's connecting an object to the earth with a conducting wire to safely rebalance a charge. It's an easy way to neutralize conductive materials. And then earth, it is large enough to easily supply enough electrons to neutralize a positively charged object or absorb those extra electrons from a negatively charged object. So here in this example, this is a gasoline truck. So it's coming down the highway. There's lots of blowing wind and dust, and it's going over bumpy roads. So it'll often become charged. So before the truck can deliver gasoline, it is grounded. And that basically, it prevents sparking that could cause those gas fumes to explode. But then that movement of gas through the hose will also produce charges. So that grounding cable is left, it's left there as the gas is pumped through the hose. All right, so continuing with neutralizing unbalanced charges. So insulators, those are the non-conductors. They are usually neutralized with ionization. So this ionization device, it'll produce both positive and negative ions. And then those ions, they're attracted to materials with an opposite charge. And those charges are transferred until that material gets neutralized. So here is a handheld ionizer. It can neutralize electrostatic charges on non-conductors. Preventing electrostatic buildup. So charged objects, they attract dust, they attract contaminants, they stick together, they can jam equipment like photocopiers. So there's these anti-static sprays or coatings that are used to decrease static buildup. Okay, so you can spray to the surfaces to prevent the buildup of charges and to basically dissipate the charges that are already present. All right, so we'll stop here. We'll watch this video on electric vocabulary.